Okay, we're back to looking at some equations. And again, you may see that over on the left, I went ahead and drew out the table. Notice my angles this time are in radians because the direction said solve each equation for theta between 0 and 2 pi, including 0 but not 2 pi. That's a tip-off. They want the answer in radians. If they say between 0 and 360 degrees, they want it in degrees. So I went ahead and listed all the multiples of 30 and 45, or all the multiples of pi over 6 and pi over 4, and what their sines and cosines are. Because if I know the sines and cosines, I can figure out tangents, because I have to do a tangent one here, and problem number 10. Now, before I start working on these and showing you how they're done, they are done very similar to the ones from the previous assignment, in that you are going to want to isolate your trig function, at least for this one, this one, this one, this one, this one, this one, and then you've got all the ones with the variable squared. Now this one, the variable is squared, but there's no, there's a cosine squared theta, but there's no cosine theta. Whereas like this one's got a cosine squared theta and a cosine theta. So you can use the square root rule here on property on this one, but here you're going to have to factor, here you're going to have to factor, here you're going to have to factor. So keep that in mind, but you try the problems prior to watching these problems worked out, see if that helps you a little bit, and of course you've got to memorize this as soon as you can. So I'm going to go ahead and pause so that you can stop the video and you can work on the problems if you haven't already done so. Or if you worked on the first, let's say 3 problems and you want to check that, that's fine, but then you stop the video and you work on the rest of the problems before you watch them get worked out completely, because it'll mean more to you if you have put some real thought and effort into each one of these problems. Pause. Here we go. Alright, so you've tried this problem, I hope, and let's show you how it's done. I want to isolate the cosine of theta, so I'm going to divide to get rid of the negative 4. I'm going to divide both sides by a negative 4. All of a sudden I got a feeling I wrote this one down wrong. I sure did. I forgot a 2. Goodness gracious. Got in a hurry here. Because it wasn't going to come out to be a nice value, that's for sure. Alright, these are going to cancel out, and I'm going to go ahead and write the cosine of theta on the left side. Now, a negative divided by a negative is positive, and 2 goes in once, and 2 goes in twice, so this is the square root of 2 over 2. Well, what's my angle equal to for a cosine? It's square root of 2 over 2 at pi over 4, see right there? And also at 7 pi over 4, so those are your 2 answers. Easy pleasy. This one's even easier, because when I divide both sides by negative 2, I get the sine of theta is equal to 0. So nothing fancy that I have to do with a radical, just 0 there. So sine, that's this column. Where do I get 0? I get 0 here at 0 radians, at pi radians, and also at 2 pi radians. But remember, we're not including the 2 pi here. So I just put that down to show you that the pattern was going to continue. My answers, I only have 2 of them, and that's 0 and pi. Here I'm going to divide both sides by 4. And I get the tangent of theta is equal to 4 divided by 4, which is 1. Now tangent isn't here, but it is here because it's the sine over the cosine. So you get 1 when the sine and the cosine, remember the tangent of theta is equal to the sine of theta over the cosine of theta. You get 1 when the numerator and the denominator are the same, because anything divided by itself is 1. So you find the angle which has that property. Well, it has it here, because you can see the cosine square root of 2 over 2 and the sine square root of 2 over 2 at pi over 4. But there's one more, because remember tangent's positive not only in the first quadrant, but it's also positive in the third quadrant, way down here. Notice negative square root of 2 over 2 over negative square root of 2 over 2 is also 1, so I also have 5 pi over 4. And I have these 2 answers here. Let me circle them here. You see how fast those 3 went? Well, these next 3 aren't going to take too much longer, maybe an extra step here on 5 and 6. So I am going to add 1 to both sides instead of having to add or multiply or divide. I've got to get rid of the negative 1 that's being added to the sine of theta so that I can get the sine of theta all by itself. Again, that's the trick, is to get the trig function, unless the trig function is squared, is to try to get the trig function all by itself on one side. So over here I have a negative 3 halves plus a positive 1. Well, negative 3 halves plus 1, which is 2 over 2, is negative 1 half. So when does the sine give you negative 1 half? Well, we know sine is negative in the third and fourth quadrants. Remember, all students take calculus. So in the third quadrant, I need negative 1/2. That happens at 7 pi over 6 and also at 11 pi over 6. So 7 pi over 6 and 11 pi over 6. Now, if he's not going to give you this table to look off of, how are you going to do on this if you don't have it memorized? And you better have it memorized, because I don't think he's going to give you a table. Next problem up. I'm going to divide both sides by 4. And I get the cosecant of theta is equal to 8 divided by 4, which is 2. Now I have a problem. I mean, I'm good with sines and cosines, and I'm decent with tangents, but cosecants and secants and even cotangents not so great. So this is where I use the reciprocal idea. I have the cosecant of theta is equal to 2. Well, the reciprocal of cosecant of theta is 1 over sine, or the sine of theta actually, it's the reciprocal, is sine of theta, and the reciprocal of 2 is 1/2. So I'm going to take the reciprocal of both sides, and I'm going to write the sine of theta is equal to 1/2. Now I'm golden here. Pi over 6 and at 5 pi over 6. So theta is equal to pi over 6 and 5 pi over 6. Again, I'm forgetting to circle these. Next one on the menu here, I'm going to divide both sides by 6 to get the secant of theta by itself. Now again, it's going to get a little bit more complicated here because it's secant instead of sine or cosine. And I can divide top and bottom by 2, so I get negative 2 square roots of 3 all over 3. Just like I did here, I'm going to take the reciprocal of both sides. The reciprocal of secant of theta is the cosine of theta, and the reciprocal of negative 2 square roots of 3 over 3 is 3 over negative 2 square roots of 3, or just the negative out in front. Now, I have a radical in the denominator, and there's no way I'm going to find that up here. So I'm going to see if I can simplify my radical by multiplying top and bottom by the square root of 3. So now I get negative 3 square roots of 3 all over. Now the square root of 3 times the square root of 3 is 3, times 2 is 6. And look at that. Goes in once, goes in twice. So I end up with the cosine of theta is equal to negative square root of 3 over 2. Oh, that guy I know. So the cosine is negative square root of 3 over 2 right here at 5 pi over 6 and right here at 7 pi over 6. So theta equals 5 pi over 6 and 7 pi over 6. See the trick on this one? You had to rewrite it if you take the reciprocal of both sides, because I don't expect that you're going to memorize the secants. So if you take the reciprocal of both sides, you had to simplify that expression, and look how nice it turned out. Now, on these other problems, because the variable, the trig function is squared, there's a pretty good chance you're going to pick up more answers. These first 3 problems here, you're going to use the square root rule, which is you're going to take the square root of both sides, and that'll pick up the plus or minus and all that. So, but first things first is isolate the cosine squared, or the cosine squared, or, well, they're all cosine squareds. So if I divide through by 4, I'm going to flip the sides around. I get 1/4, and if I take the square root of both sides, now I don't think he's going to have you write in every single one of these steps that I'm going to do. By the way, the square root of 1/4 is the square root of 1 over the square root of 4. So I get the absolute value of the cosine of theta is equal to 1/2, which means that the cosine of theta is equal to plus or minus 1/2 to get rid of the absolute value bars. So don't forget that plus or minus. Now that gives me probably 4 answers here for theta. 1/2, that happens at pi over 3. 2 pi over 3. 4 pi over 3. And 5 pi over 3. Okay? Again, you need to memorize that, because you're not guessing 4 answers like that out of thin air. Now, the next guy up, there's an extra step here, because I just don't divide. I do have to divide by -4, but first things first, I have to get rid of the -4 here, and we always undo adding or subtracting before we undo multiplying or dividing. So I have -4 cosine squared theta is equal to -3. I divide both sides by -4. Hopefully I left myself enough space. I have cosine squared theta is equal to negative over negative, that's positive 3/4. I'm going to take the square root of both sides. Now the square root of 3/4 is the square root of 3 over the square root of 4, which is the square root of 3 all over 2. So I get the absolute value of the cosine of theta is equal to the square root of 3 over 2. So I get cosine theta is equal to plus or minus the square root of 3 over 2. And I'm running out of space here. I'll bring my theta equals way over here. So that happens at pi over 6. That happens at 5 pi over 6. That happens at 7 pi over 6. and that happens at 11 pi over 6. All right. There's a fun time. All right, this next one is very similar, except I like the fact that all I have to do is add 1 to both sides. I don't have to divide, so I don't have to worry about a radical. Take the square root of both sides. It's kind of nice that for whatever reason he just gave all these cosine squares. So that's the absolute value of cosine of theta is equal to 1. So that means the cosine of theta is equal to plus or minus 1. So that means theta is equal to 1 at 0 radians, at pi radians, and back here at 2 pi, but remember 2 pi is not part of your replacement set here, so it's just these two answers. If you put a 2 pi down, you probably take off at least 1 point. Alright, now the last three I'm going to have to factor, and the first two out of the last three are actually kind of nice because they're already kind of set up in a form, like a standard form for a quadratic equation. This guy, I'm going to have to get this term over to this side because I have to have it set equal to 0. So I'm going to factor this, but not with like an x and an x. What's being squared here is the tangent of theta, so I'll factor with a tangent of theta and a tangent of theta. And I got to get a plus 1 with a plus 2 in the middle, so plus 1 plus 1. Well, it's the same factor. Don't set both factors equal to 0. You only have to do 1 because it's the same factor. I have the tangent of theta plus 1 equals 0 because this times this is 0. One of these has got, or both have to be 0. Subtract 1 from both sides, and I have the tangent of theta is equal to negative 1. Now, back here, there it is, it was equal to positive 1, and I said, well, remember they have to be the same number. Well, to get a negative 1, they have to be opposites. They have to be the same absolute value, but opposite values, and that occurs here at 3 pi over 4. It's either that they have the same absolute value, but this is negative, this is positive. Positive divided by negative is negative. This is going to be negative 1. And then down here at 7 pi over 4, the same effect. So 3 pi over 4 and 7 pi over 4. Okay. And that's it. Okay, now the next one also factors. It doesn't factor into the same factor twice. That would have been really convenient. So 2 cosine theta and cosine theta. And I need a 1 and a 1, and I got to get a minus 1 in the middle, so this is negative and this is positive. So I get 2 cosine theta plus 1 equals 0, or cosine of theta minus 1 equals 0. So subtract 1, I get 2 cosine theta equals negative 1, divide by 2. I get cosine of theta is equal to negative 1/2. Here I'm just going to add 1, and I get the cosine of theta is equal to positive 1. Well, that's or, that's the word or there. So now I look up negative 1/2 for cosine, 2 pi over 3, and 4 pi over 3. So theta equals 2 pi over 3, 4 pi over 3. And when does the cosine of theta equals 1? Well, we had that just a minute ago at 0 radians and also 2 pi, but that's not part of our replacement set. So, or theta equals 0 radians. Now, you could write it like that. I think he'd probably accept it. Or you could just write that theta is equal to 0, 2 pi over 3, 4 pi over 3. He'd probably be okay with that. He might even be looking for solution sets with the braces. If he wants a solution set, give him a solution set. Put braces around it. Okay? Any of those would be fine, I would think. Okay? This one's got an extra step because it's not in standard form. I don't have it set equal to 0, and I have a negative lead coefficient on the cosine squared. So what I'm going to do is I'm going to add 2 cosine squared theta to both sides, so that these cancel, and I'm going to get a 0. Now over here, I'm going to try to rewrite this in such a way that it's in kind of like descending order. I'll start with the cosine squared, that's 2 cosine squared theta. And then the plus cosine theta, that's kind of like the linear term, and then the constant, which is the minus 1. Well, this thing's going to factor, and I'm going to factor it, and I'm going to go ahead and set it equal to 0 on the right. So this is 2 cosine theta, and this is cosine theta. And it looks like a 1 and a 1 again, only this time it looks like a plus here and a minus here. Oh, it's the exact opposites. What a guy. All right, so I said 2 cosine, the answers are not opposites, but it's the exact opposite values here. 2 cosine theta minus 1 equal to 0, or cosine theta plus 1 equals 0. Here I'll add 1 to both sides, and I have 2 cosine theta equals 1 divided by 2, and I have the cosine of theta is equal to a half, which I got to get to in a second. Here I'll subtract 1 from both sides, and I have the cosine of theta is equal to negative 1. Well, let's see. Positive 1/2 occurs at pi over 3 and at 5 pi over 3. So here we'll just write it all at one time. So I got pi over 3 and 5 pi over 3, and I'm going to get some answers from there. Negative 1 at pi. So I'm going to put them in order from least to greatest, so and that's it, just the one from here, pi. So I'm going to write pi over 3, pi, and 5 pi over 3. It looks kind of cool that way. Okay, and that's how the equations solve. But you have more than equations. You also have to prove some identities. Now remember, when you prove identities, fortunately you don't have a million of them, you only have 4 of them. But when you go to prove identities, remember, take the more complicated side and simplify. Look for substitutions, like I could use a substitution here for tangent of theta, and that'll help simplify it. Look on the left side. On the left side, I would probably multiply those together, kind of a thing. Here I might look for a substitution here, a Pythagorean substitution. Here I'd work with the left side. It looks like I'm working with the left side all 3 cases. So, statement, reason. You try these and ask me questions if you're unsure. Alright, I hope this video helped a little bit, and you can get a good chunk of this out of the way. And of course, I'm always happy to help you if you have questions.